purpose of this video tutorial is to help you determine whether or not your select out blocks are producing the desired behavior. So in this case, the select out block we're looking for is block 70. And we'd like to find out whether or not this is producing the desired behavior. So first of all, what is the desired behavior here? Well, we think that if we have some bad guy points remaining, then we should keep on firing. If no bad guy points are remaining, then we want the item to just exit the model. So the first cut testing for an exit, those select outs, is to make sure that when you run the model, that you're going to be able to see throughput to both of the pathways. So we don't want either of the pathways here to be permanently blocked inside the model, or that indicates that we have a problem. The point in having the select out is because we think that there's some possibility during the course of the model behavior that we're going to be able to take both of these pathways. So keeping in mind that the random behavior includes elements of the behavior is not completely random. So sometimes you can have select out blocks which are set to random behavior, which is actually the default. So if we open up the block dialog here, random behavior is one of the choices. So you can just make it random. In that case, there's really nothing to test because the random number generator does its thing and it'll just pick each one of the outputs in proportion to what you expect. So that behavior doesn't need to be tested. So what does need to be tested is, in this case, we're using the select connector. You can also have it selected by a property, which is also known as an attribute. This video does not cover doing that, but you can use similar techniques. In this case, we have a select connector. So the select connector, what that does is it explicitly directs which pathway is going to be taken by each of the input values. So the select connector tells it which input value is associated with each pathway. Now, the connectors happen sequentially. So you can start with connector number 1, then the next connector down is going to be, or output down is going to be output number 2. The default is to start with the select, the top pathway being associated with the value 0. So then if the select connector is 0, you're going to check the, or go through the top pathway. If the select connector is 1, you're going to go through the bottom pathway. Okay, so let's go ahead and run this, and we expect to see if this is working properly, that we're going to see output at both of these pathways. Okay, so let's open this up. And then we'll notice that we're seeing 3 outputs at the bottom pathway and no throughput at the top pathway. Now, that's not necessarily an indication that we have a problem. Again, there's a certain amount of random behavior going on inside this model. So we could have just seen something that was a one-time outlier, and maybe the model's really working. So we're going to run it a few more times, and we'll notice each time I run this, I'm getting the exact same outcome, which seems pretty suspicious. So again, we are not seeing any throughput to the top, through that top output. And so that's what is making us think that this model is indeed not working properly. Okay, so that's the first tip off. So if you see something where you're not getting throughput to both pieces or all the exits, again, you can have more than 2, then that's telling me that I likely have some type of a problem. And you should run the model repeatedly. If you can't get the outputs to come through, then there's some kind of a problem. So the question is whether this is a problem with the select connector or whether this is a problem that you're truly never getting the intended inputs. It could be both of those. So if you're never getting the intended inputs, then it could be that the issue is not with this select out block. So we're just going to cover how to determine that it's actually with the select out block. And what we can do is then isolate the upstream behavior by directly connecting in a known value to the select connector. So if we think, okay, so if we need to, again, know what the known behavior is. So we're going to temporarily disconnect the select connector so that we're isolating the behavior of the select connector itself from the remainder of the model. And so we're going to pass in then, instead of this calculated bad guy hit points remaining, we're going to say, well, if the bad guy actually has 0 hit points remaining, then we think that we should be following this exit pathway. So I'm going to go get a constant block. And I'm going to just set this constant block. In this case, I'm going to set the value to 0. So if I have no health points remaining, then I should be going through the exit block. So now every time I run, I expect to only go through this exit block. What's actually happening is every time it goes through, it's going through the top block. So every time I have 0 health, every time I pass in a 0, I'm going through the top block, which is not the desired behavior. So that tells me that I have my connections reversed. Now, there's no way that the way the select connector works, I cannot reverse the sensibility because it only counts downward. So I can't make this be the top connector. I have to actually reverse what it's going through to fix it. So now I'm reversing these so that if 0 goes through, it goes to the top connect. It goes through the top. It always goes through the top connector when I put through 0. But now if there's really 0 health points, that is going to give me the desired behavior, which is exiting the model immediately. Okay, so now I open this up and I'm going to only see throughput through the top connector, which is what I think is going to happen because I've directed it only through the top connector. Now the top connector again represents no health points left. So what I expect to happen here, if I hook this back up to the remainder of my model, I'm expecting to see that I'm going to be going back to do more firing, again, assuming that there's some probability of kill that is not, 1 each time. Now notice that this probability of kill is set to 0. So that's also going to cause the behavior that's not going to be what I think it is, right? Because if we have no probability of shooting something, then we're not ever really going to lose health points and we're not going to be able to ever exit the model. So that actually is going to cause unexpected downstream behavior as well, as I'll show you. But now we've hooked back up the connector. So in theory, we think that we should be seeing a bunch of times going through with remaining health points, and then eventually we'll run out of health points. So that's what we think is going to happen. So now when we run, what's actually happening is I'm seeing the throughput at the pathway number 1 or output number 1, the bottom output, which I'm expecting to see, but it never exits. So is that do we have a problem with the actual select connector? No, we hooked up we can hook up the constant block to it to show that we get the desired behavior. So it's not, the sensibility isn't reversed anymore. And the problem is actually upstream. So in this case, the upstream problem is that we have a probability of kill of 0, which means that we're actually, the model is working correctly. We've just put the wrong input in. So if we set it off to 50%, so 50% of the time we're going to be losing health points as we go through, we should see a mix of results at the select out block. And if we run this, and we now see that there's no throughput from that exit either. Okay, so let's just check and see what we have going on here. So we do have a 50% there. Let's check to make sure that the bad guy health points. And let's just check this graph to see if bad guy health points are actually getting decremented. Okay, so it looks like the health is going down each time, but it never gets down to 0 here, right? They only go through one pass. So again, is this a problem with the way the select out is working? Not necessarily. So what could be happening in this case and why we're seeing this behavior is that we're actually not being able to decrement a sufficient amount of health before we get all the way through the model. So if we set the red health, we can set the red health down to see if that helps any, because the red health is actually being reduced. It just never has an opportunity to get down to 0 before we wind up exiting the model. And it could be that we need to let it run a little bit longer. So if we aren't letting it run long enough, that could be an issue because we're not letting it go back enough times to fire. Let's check and see at the back for more, how often it's going through here. So notice that it came back by, initially we created, so what this select in is telling me is that it came through the top output 3 times. That's when they were initially collected. And then 9 times we came through this back for more before the simulation was stopping. So I'm going to set to make sure that this isn't a problem with it just not running long enough. I'm going to set the end time to be much longer. And then I'm going to try running and see what I'm seeing here. Okay, now notice here, we're actually seeing the items exiting and that we're seeing that red fires at B a number of times. We have throughput to both areas. And also, if we think about how many we're expecting to see through that top, well, we only created 3 items in the first place. So the fact that 3 items are exiting, that is the proper and desired behavior, and that we're seeing a number of firings happen before we go through that exit. So this is leading me to believe that the select out behavior is actually working as intended.